Let's get started, guys. There's a lot to go over. It's definitely going into lunchtime now. Yeah, Brian, come on, let's go. I want to thank everyone for coming. Happy Friday to everyone. For those of you who don't know me, my name is Jesse Mock. I've been with the R&D team here for about 18 months, and I've had some opportunities to work on some really interesting mobile application development. My specialty has been in iOS, and some of the things I've worked on are one that you all are very familiar with, the JMSC forum. I've done various proof of concepts for the VPC, and then I don't know if you guys have heard of an app called NextDrive, but it allows you to interface with your vehicle's OBD data and get live driving feedback, real-time driving feedback. As I stated, I've been specializing in iOS for a few years, and I've done some Android, at least enough to be dangerous. But the past few months, I've been focused heavily on Xamarin, and I'm really excited to show you guys how to build an iOS and an Android application from scratch. Let's take a look at our agenda today. We're going to go over some native approaches to native application development, purely native, versus cross-platform, and then we're going to go into some high-level architecture. Then we're going to take a look at what it is that we're going to be building, and then we're going to go ahead and do it. So if we look at the completely 100% indigenous approach to mobile application development, if we're being tasked to develop an application for iOS, Android, and maybe Windows Phone, maybe, we're going to be using Objective-C, we're going to be using Java, we're going to be using different IDEs, three different languages. So can anyone tell me what some of the problems with this are?
Business logic.
Business logic is a big one. Huge. Since most of our business logic is shared, roughly about 70%. It could be 70, it could be 80, 90, especially in Xamarin. Some other problems with this are, being familiar with all the different languages. You have to have a team that's versed in all these different languages, and having experience with the different IDEs. So some other problems are keeping the code synchronized for better synchronized releases, so that when your iOS application is complete, because the native iOS developers is finished, the Android guy could be lagging or the Windows guy could be lagging. So your time to market can vary, and it's harder to keep that synchronized.
Higher cost of development and maintenance.
Oh yeah, much higher cost of development and maintenance. So has anyone written anything native? I know my guys have.
Some Android.
Okay, some Android, good. Some iOS. That's about it? Okay. Now if we take a look at the Xamarin approach, or the cross-platform approach, obviously, we have one language, C#, .NET, which is great for our company. We're a .NET shop, right? So it's important to note, let's imagine that these are all separate projects in a solution. So roughly, as I said before, about 70% of our code is shared. Each platform-specific project contains roughly about 30% on average. It could be even more than that shared. It could be 90% shared, especially with something like Xamarin Forms, which I won't go into. Maybe at the end if we have time. But so has anyone developed in Xamarin? Has anyone done any Xamarin development? Oh yeah? Okay. A little bit? Cool.
Do everything.
Everything. So what is our goal with cross-platform development? Obviously, we want to be able to submit our applications to the Apple App Store, Android, Google Play, and Windows Store. And what do we need to submit to these stores? Well, for iOS, we need an iPhone application package. For Android, we need an Android application package and a ZAP file for Windows. It's important to note that with Xamarin, when you build these packages, they look and feel exactly as if they were created in their native platform, because the UI controls and screens are are the actual bindings to the native controls, to the native platform. How do we get these builds? Well, as you saw before, we have our development project here, or our development solution here, that contains, again, our shared code and our platform-specific projects. So let's take a quick look, just real high level, at the Xamarin architecture. Typically, again, I'm stressing this over and over, we have about 70% shared code, and this is usually in the form of, you know, our persistent storage, our web service access, our business logic, object models, validation, etc. And each one of our platform-specific projects, you can think of each one of these boxes as a different project and a solution. So each one of these platform-specific projects has, you know, an application layer, which is the platform-specific code for that project, and that references directly to the shared code project's business layer. Now, the UI layer is for Xamarin is actually the native, comprised of the native controls and screens for that platform. You also need the references to the native SDKs for that project. And there's not too much dialogue, not too many more slides. Actually, we've gone over some of the basics, some of the fundamentals. We're going to get into the good stuff now. So let's take a look at what it is that we're going to be building. You may have seen the Tasky app. We're going to build the Tasky app. This is an application that allows us to create tasks, modify tasks, mark them complete, and remove them. And of course, view a list of tasks. Now, if we take a look at the iOS version of this, this is a typical master detail type of UI. So we have our list of tasks. We can mark them complete. And when we go to our detail, we can either see the details on that task. We can create the tasks and, again, perform the full CRUD operations on the task. Just real quick, take a look at our Android application. So these are what it should look like when we're done, when we're finished. So let's do it. Let's start out with the iOS application. Just give me a couple minutes to transition here.
Anybody have any questions so far right now? I mean,
So one of the advantages like one ID and a business logic in one place, but there's 20% of the code that seems to be native. So this part of code that's native is you set the business rules and whatever you need to the .NET code, the Xamarin code, or what is that?
so I mean, at the end of the day, what we really want is to get essentially apps published into 3 different stores, right? The Google Play Store, the App Store, and the whatever the Windows one is called. Windows Store? The Marketplace, yeah, something like that. Yeah, the Windows Marketplace. That's how much we want to do with the Windows one. But so each of the 3 stores, and Jesse had a pretty good slide on that, the idea is to essentially have, you know, each of those stores requires basically a different kind of file, right? Like an IPA, an APK, and whatever other file, right? So you need to build somewhat those files in, you know, using the same tool. And the IDE here, you can actually use Visual Studio the same. There's people that use Visual Studio, people that use Xamarin. But essentially, it's a compiler that knows how to build out those binaries that you can target and you can submit into all of those 3 different stores, right? So it's a compiler that takes C# code and outputs binaries, much like the Objective-C or Swift compiler outputs your IPKs and
So it seems like the breakdown 70-40 is
It's typical.
Like 95-5. If it's just compilation step at the end.
Yeah, that's a good point. So the 70-30 and why it's not 95-5 is because being a mobile app, there's a lot of the navigation, the behavioral, the actual buttons and the controls and things like that. And even though you can sort of think of it as, well, I can almost have common code for all of those things on how a button looks like. There's a lot of frameworks like the hybrid approach takes HTML and you can sort of like, you know, code the button in HTML and whatnot. The construct for each of the platforms is very different, right? In iOS, you have the back button over here, and the other one is like 3 dots. In Android, is like 3 dots. iOS has like a navigation controller at the bottom, and Android has it at the top. Like, you know, the GUI part of that is very, very different. So it's really hard to try to make it in common constructs. There are some approaches to do it in common construct. We're not going to cover it here today. Like Xamarin Forms is one of those that tries to somewhat say, well, if what you want to do is like a tab approach, then just, you know, write this kind of code and tell me that you want 4 tabs, and I'm going to transpose that into at the bottom for iPhone, at the top for Android type of deal. But it's really not like the best. It's very hard to actually have rich interfaces in the client with those. So the actual interfaces, you have to build them in the native approach. And that's what the 30% comes in, right? But basically everything that goes behind the actual behavior of those controls, like, you know, what happens behind the click of that button, what happens when you swipe from one window to the other, yada, 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 that is all in the 70%. I mean, the behavior of the app is going to be the same whether it's an Android or iPhone app, right? It's just going to happen to be looking a little bit different.
Okay.
So my bad.
I have a question. How native is it actually uploading native code, or is it sitting
Yep.
on the
Yes.
environment?
The binaries are fully native.
Right, but is there a package copy of the mono runtime
No.
inside that?
No.
No, they recompile actually to pure
Okay.
native.
Yep.
So,
Yeah.
so understand. So another thing about Xamarin is they're a huge contributor to Mono, like Ricky mentioned. So, and they're actually allowing .NET to run pretty much anywhere. We run .NET on Linux and everything else now at this point. And so the two together are allowing them this capability of doing that generation of true native code. Because even on the Mono stuff, Mono actually does generate native to run on Linux and everything else as well. So.
All right, let's get into it then. So
Coding time.
yeah, I've created a blank solution here, and I'm not going to go all over the IDE and show you guys, you know, explain everything right now. I'm going to kind of go over it as we go. So I'm going to go ahead and add a new project. Actually, let me just start out by, I'm not going to code our shared project. I'm going to just load it up here. Sorry. So we have our core project. Okay, so we have our tasky core. So this is where we have our task object. And we have our manager class that allows us to do the CRUD operations on that task.
Jesse, I'm sorry, I don't mean to interrupt you, but can you maybe like just give a little intro of what we're looking at in here? I mean, some people are just not familiar with what we're
Yeah,
looking
so the tasky core, this is our shared project. This is where most of our code lies. And again, this is where we have our task object. We have all of the SQLite persistent storage logic in our task repository.
So that's the 70% of that you described.
Typically, yeah, typically. And
Jess is using, just let me jump in. Jess is using Xamarin Studio, which is different from Visual Studio. It's very similar. It's almost identical. It just happens to be that it's focused more towards the mobile aspects of it, right? You don't have all of the super ultra richness elements of Visual Studio. It's a lot more simple and looks almost like iTunes, I like to say, right? But you know, it has a play button, you play, and it runs in the phone, and that's pretty much it, right? I mean, it has code completion and things of that nature. But if you really are a hardcore Visual Studio dev, you can go with Visual Studio. Visual Studio has a plugin to it that you can basically do the same things in there. But project-wise, solution-wise, all of those things is pretty much the same concepts that you have in Visual Studio.
so what do we want to do? We want to add our platform-specific project. So we're going to create a new project, and we have a lot of templates here. We could create a new Android project, iOS project. We could create an Apple Watch project. If we had a lot of time, I would create a blank iPhone project from the empty project template. But in the interest of time, I'm going to create a master detail project. I'm going to call it tasky.ios. I'll close our core here. Now, we're going to have to reference that core project. So I'm going to reference the core project. And we're also going to have to add couple NuGet packages for our platform-specific instances of SQLite.
And we're doing this because we want to connect to the database where we're going to put the tasks and things like that, right?
So we have our PCL here.
So much like in Visual Studio, when you want to connect to a data store, you need to use the system.data, namespace, and all of the SQL connector and things like that. In here, it's pretty much the same. They have basically mapped every single one of those things,
There we go.
either directly as part of the framework or through packages. This is like, I mean, it has support for NuGet, so pretty much everything that is available in NuGet you can get through here as well. So it's very reliable from that standpoint.
So I'm going to load up our storyboard. Those of you familiar with iOS development will know what a storyboard is. This is where we do all of our UI manipulation. And the first time it always takes a little bit. So let's go into our master view controller here. We're going to have a master and a detail view controller. And let's add those references to our Tasky API, Tasky core, and our platform-specific instance of SQLite.
This code should look pretty familiar for pretty much everybody here, right? I mean, there's no black magic here happening.
Okay, so we have our storyboard loaded. Now we have our navigation controller and our master detail view controller. Now let's go ahead and rename our master view controller to Tasky. And we're going to call this task details. And okay, so our master view controller, this is actually a UI table view controller. And it contains nothing more than just a table view with a table view cell. This is a default table view cell with just a simple label. Our detail view controller, we're going to need to wire up to enter our details and save and delete them. So going to need a label. And let's go ahead and create a few of these.
Windows forms.
Yeah.
Windows forms, right? This is pretty much the same thing, just like with a smaller surface to drop stuff, the surface of the phone.
Yeah. Now it's important to note that I could pull this right out into Xcode, and the file is the same. The file structure is exactly the same. And I could do my UI design in Xcode and come right back to Xamarin Studio, and it would update. So let's call this task name. Let's call this note. And we want to mark it complete. So these are UI labels. So I'm going to add a text field here for our entry. And one more. And we're going to add a UI switch. Mark it complete. So what else do we need? We need a couple buttons, right? So these are UI buttons, just like in Xcode. And we're going to need to label our some of our fields here. So we're going to say txt name, txt note, switch done.
Put some ID so that you can reference the back in the code.
And the code
So
behind.
pretty much it's pretty straightforward. I mean, this is
And
nothing new, right?
btn save,
By the time that you walk out of here, you'll be like, we're all mobile developers now.
btn delete. So you get the idea. Now we're going to need to label this save. So I said as I would go, I would kind of explain a little bit about Xamarin Studio. So obviously we have our solution pad over here, our code editor, in the middle, and we have our global search, and this will search every file in our solution. We have our toolbox and our properties window for each of these controls. And I think I really didn't have to explain that. I think it's pretty self-explanatory, but I just thought I should go over that. So one more and delete. Now, our main view controller here is backed by this master view controller class. Our detail view controller here is backed by the detail view controller class. Now, this is going to give us a lot of boilerplate code that I don't need, so I'm going to go ahead and remove some of that right now.
Just let me pause in there for
Sure, go
so
ahead, fill in.
This is pure MVC. This is, I mean, ASP.NET MVC, and these are like siblings. They are using the exact same pattern. You have control in the back
I switched
that
it.
is tied to, it's, you know, convention based for the most part.
Yep.
And you know, if you double click on the surface for a button, you will get down to like the event handler for that thing. I mean, it's very, very similar to what we had before with Windows Forms, what we have today with ASP.NET MVC,
Okay.
Web API. Like all of those patterns are pretty much the same things. It's just pure, good old MVC on phone. And when I say it's convention based, is you'll notice that there's not like individual views for each one of the screens, but you have this overall storyboard, and depending on what the actual name that you have for each one of the screens inside of that storyboard, you can actually you can get the automatic mapping into your class that is named differently. You see that it's a detailed view controller, master view controller. So everything that ends with controller is considered a controller, that inherits from the controller class, yada yada yada, kind of things, right?
So we're going to need a list of tasks, and we're going to need our reference to instantiate our API to our shared project. And using a little bit of dependency injection, we're going to pass our platform-specific instance of SQLite to the core. And let me load up here our completed project, just so that I can steal something from it. Our completed solution. We can load both of those at the same time. Now, I'm going to steal this DB helper class. This is just going to give the core a path to our local database in iOS. So we're going to pass that to our API. Database path, and there we go. So what do we want to do? We want to get tasks and load them into the table view.
You can see that it has support for async, synchronous programming. I mean, pretty much everything from .NET except I/O, which are related to the file system, which obviously is different in mobile than it is in Windows. None of the I/O libraries are supported here. So file.anything, forget about that. Obviously, there's no file.anything here in mobile, right? So there's specific libraries for that. What else is it missing? I mean, it's a couple of things that are not supported, but pretty much 98% of the framework is supported. And for all of those APIs, they're essentially mapping into the core library supported by each one of the operating systems. So you were asking before, Ricky, whether this was actually built into native code. Yes, it is, because what Mono essentially is doing is taking all of the constructs from iOS and it's finding their corresponding mapping into the .NET framework, and they're writing essentially a transposer in the middle. That's pretty much what this is. They're compiling from one language to the other to the framework.
So we're going to need to get our tasks from our core, and we're going to need to load them into the table view. So to do that, let me just explain what viewDidLoad is to some of you who don't know. ViewDidLoad is the entry point into this class. When the view loads, it will call the viewDidLoad method only once. When we come back to the view, it's not going to call viewDidLoad. So we need something else. We need to override the viewWillAppear method. And this will get called every time the view appears. So when we go to our detail and enter some of the information and come back, it will call this. And why do we need that? Why do we need to call getTasks from that method? Because every time we come back, we want to refresh that list in our table view. So if we set our table view source to our data source here that we've created below here, and in the constructor, I'm passing the tasks that we've gotten from the API. That will set our data source, and then on that we will call tableview.reloadData. When we call reload data, it will trigger our data source and call how many rows do I have. Can you guys see the code okay, or do I need to blow it up a little bit?
By the way, all of those are APIs specific to iOS.
To iOS.
Right? So you would not have something that is called number of sections in Android. This is something that is
Right.
specific to iOS. Therefore, in here, much like you have a window loaded or whatever the old Windows Forms APIs were, there are API specifics for Android, API specifics for iOS, and right now he's on the iOS project. Therefore, the APIs that he's coding are the iOS specific APIs, right?
Right.
That's so. Yeah, that's part of the 30% because those methods are only from iOS.
Right.
But most of the actual, hopefully those methods will be relatively short, and they'll be calling the logic from the core, which is around, on the reminder 70% of that.
So we'll come back to this, but let's go ahead and go to our detail view controller. We're going to need to set that up. I'm just going to steal some things from our master. And we're going to need to declare a public task here that will pass from our master so that when we have an existing task, we can edit that task. So what is it that we need here? What do we need to do? We need to save a task. And we need to delete a task. So how do we save a task? We can come to our storyboard, and we can actually go to our Save button, double-click to create the... Oh, did that just create a constraint? Okay, double-click to create, an event handler. We can place that in here. We'll do the same for the delete button. Okay. So we have our events here. Just pull them up here. So when you select the delete button, we will call save task. And when we select the save button, when we select delete, we will call delete task. Right, where am I? Code completion. There we go. So in our save task method, we want to check if our existing task, we have our existing task, let's rehydrate it with our fields in our UI. Does that make sense?
This is Abby, that note on the events themselves says touch up inside. Another one of the APIs specific to iOS, right? Much like in widgets we have the click event for button. In here, there's no click, it's touch, right? So the name of the event, touch up, drag, things like that, right? So in here, it's just decoding one of those events.
So we've rehydrated our task object, and we need to actually update the task. So what we can do is we can call our API update task, pass that task object, and then we can actually call to our navigation controller and pop this view controller off. So when we save our task, we're going to pop the view controller off the stack.
What is that pop, Jesse? What does that mean?
So that means that it's going to actually go back to our master view controller. It's going to pretty much release this view from memory.
And where do you get that navigation controller? Where's that come from? Something that you coded, or?
No, the navigation controller. We were given with this template.
So I know what it is. I just want you to tell us to do the rest of the team.
So
I've got a question for you.
sure.
So does the framework here provide any type of mechanism for just the two-way data mining, just right out of the box, right? So typically with the XAML type stuff in just .NET, right, whether it's WPF or Silverlight or whatever, there's a mechanism for two-way data mining where you just define where the binding is, and this basically auto mapping of the field to your model is basically taken care of for you. Does Xamarin provide that? Does it have that?
Are you familiar?
No, it doesn't come with anything like that out of the box. But you do have, again, access to, you have access to NuGet. And in NuGet, you have like, exactly. You have any number of auto mappers that you can put in place and auto data bindings. Whichever is your, there's like 700 of them, so just pick your poison, I guess.
Any restrictions on what NuGet packages you can use?
Yes, there are restrictions on the NuGet packages that you can use, and it's very much dependent on the actual dependencies of that NuGet package. So if you have a NuGet package, for example, that deals with the system.io, it will not be supported here because it depends on the file input, IO operations, things like that, right? Exactly. But most of the NuGet packages that we all love are going to be there.
So if we're starting from scratch and we're creating a brand new task, we're going to go ahead and create a task object. And this is the done switch. Done. And then we will want to add that task. That's fine, I guess. Thank you. Call this new task. So that should take care of creating our tasks. And let me make sure I have everything here. We're not going to need this for this demo. Save, and let's just go ahead and build, see if everything's going to build right. We're going to want to start off with our switch in the default off state. Okay, we don't need this guy. That was part of our boilerplate code. So when we reload our table view, again, it's going to call rows in section, and it's going to get the number of tasks that we have. And then based on the number of tasks that it returns, it's going to get the cell for each one of those rows. So if we have 4 tasks, here we will return those 4 tasks, and it will call getCell 4 times. And we have what's called an index path to give us those rows. So row 0, 1, 2, 3, 4. So when we get the first cell, well, first of all, let's get the task for this row. So equals tasks at this index path. So if we have the task, we can actually assign it to the default text label in that cell. So task name, I'm just going to be real basic here. Let's say task. Note. So that's going to give us our task name and our task note. So let's run this. We need to set our startup project to Tasky iOS. We don't want to simulate in an iPhone 4. So let's select the iPhone 6, and we need to tell this if it's going to animate or not. It doesn't. If you pass false to animate, it'll just pop off. If you pass true to animate, it will, give you a little default animation as it goes. So when we run it, we have our table view here, but we can't create a task until we create a segue to our task details. So this would normally be what's called a UI bar button item, but I'm going to just use a button in the interest of time. Give it a little plus sign. Make it look as good as we can. And I'm going to write justify this. Because if I had used a bar button item, I would have had to supply an image. And again, with the interest of time. So we can simply control drag from that button to any view controller, or any view in this case, that we want to go to. So when we release, we're going to create what's called a push segue. A push segue will allow it to push the view controller onto like a stack, and a modal segue works more like a popover. You guys know what a modal is. So when we do a push segue, now we have 2 segues. We have the default one from our table view cell, which is here. As you can see, it's highlighting the table view cell. And we have the segue here for the button. So if we rerun it, okay, we have our table view, and we want to create a task. So we're going to go to our task details. It's a pretty awesome looking UI, huh? Let me make it a little bit better here. I have to stop it. And sometimes you have to reopen the storyboard to get the toolbox and the properties to come up. It won't take too long the second time. Okay. So let's just add some placeholder text and get rid of the default text. So how about type a name, type a note, get rid of this guy. I think we're all set there. So let's run it, and let's actually create a task. When we create a task, let's put a little breakpointer on our save task. Go back to our simulator, and let's just say task 1, note 1, and let's save it. So when we come here, we haven't given this view controller a task, so it should pass this, and it should create a new task. And if we don't await when we add the task, and we try to pop the view controller, then it will freeze. So this is necessary here. So we add the task. Let me take this off, and there we are. We have our task.
Come on,
Exciting, exciting, right?
Round of applause there. There you go.
I gotta say, it's pretty hard to code and talk at the same time. So, but that was pretty quick, right? To create something so quickly. Task 2, note 2, you get the idea. Where does our delete button?
It's still on the screen.
Right? Yeah. I mean,
In the
that's
store.
in the store. Yeah. It's like,
So what happened
you
to
guys
our
are a tough crowd, huh?
what happened to our delete button? Our delete button, yeah, it created a constraint. That's a different topic completely. So now it should show up. Okay, so we have our tasks. What happened to
You can
task
see that
2?
even after it turned
Task
off,
two.
came back on, the data was persisted there, and the first node was still
Note
turned
two.
on, right? It's not
And save.
different than hardcore stuff, man. It's telling you.
Task 3, note 3. I'm not going to create 100 tasks, don't worry. Okay, now we don't have a way to mark these complete, and they're not populating when we go to our details. So on our master view controller, anytime we initiate a segue, it will call prepare for segue before it actually goes to the next view controller. So this is some of the boilerplate code that it gives us. Now, when it creates these views, it creates a segue for this cell, and it actually labels it as, in this case, show detail. So when we come in here, we can actually, let me just be explicit and say, let me say existing, this is our existing task. And that's our tasks at this index path. So we're calling for the table view index, the index path for the selected row, the row that we've selected. And we're getting our task at that index path. And then we're passing it to our destination view controller. So dot task equals existing task. So when we come to our detail view controller, when we load, we can actually say here, if task exists, and populate those fields. So the name, task.name, notes,
Your data binding again.
task.note, and the done switch, we're going to turn on or off, whether or not it's been marked complete. So,
Just a time check in there.
yeah, this is pretty much it. Let me just go ahead and add one more thing to our master. We want to be able to see if it's been marked complete. So we're going to take advantage of the default accessory view on the cell. We're going to say that this equals the table view cell accessory check mark if our task has been marked complete. So if it's not, then accessory none. So if our task is complete, add the cell accessory with the check mark, and if not, then done. Let's see what happens. What do we got here? Let's put our semicolon.
Only because of the error handling, I would change from Eclipse and Android development to Xamarin.
Oh yeah, that's great.
Find that
Code
problem right
completion is
in the
big
most
too.
type of exceptions that you get in Java when you have
Yeah.
an error. And it's-
So if we go to note 2, there we have it. It's loaded in. And when we mark it, if we want to mark it complete, we can save, and now we've marked it complete. We want to go back to our task. Thanks. Revision 2, save, and the text is updated as well. So since it's complete, let's go ahead and delete it. We can delete it. Oh, we haven't done anything yet. And that's the last thing we need to do. That's really quick, really simple. So let's say if we have our task, and delete our task. And let's go ahead and pop that again. And delete, yeah, yep.
By the way, Jess is doing something that you should not do, which is async void, but that's a topic for a different conversation. But it works for this.
Very rushed.
Yeah.
Okay, so we want to delete this guy. We're going to delete it. And again, since we're coming back, and every time we come back, it's going to call view will appear, which gets our tasks, refreshes, reloads the data. And that's about it for iOS.
So if you had to go and do now your Android app, like where do we go from here? Say that we want to basically have all of this same behavior in an Android app. What do we do?
Yeah. So in the interest of time, and I figured
You don't have to do it. Just walk through the scenario.
Okay. So we would, yeah, I won't do it, but we can go here and we can add a new project and create, add with the Android template. You don't want to?
If you want to go ahead, but I mean, I know some people.
Yeah, I mean, we have 10 minutes. We do have, you guys probably have questions too, but do you guys want to see a little bit on the Android or?
Yes.
Yes.
Real quickly. Okay, so I've
Do you have a loaded project?
okay. Yeah, I have a starter project that's kind of mostly complete.
Okay.
You know what?
Thanks for coming.
Thanks. Why don't we just go right into the completed project here?
Yeah.
So we have our completed project. Now, Android is a little bit different in that we don't have view controllers. We have activities. Let me close our iOS stuff here. So, and we don't have a storyboard. We have individual layouts. And it's important to note again that each one of these layouts, you could design in Eclipse, you could design, they're just, XML files. So if we look at the main here,
There's
we
a
can.
note that I just wanted to add there, which is doing Xamarin doesn't preclude you from actually having to learn the APIs of iOS.
Right.
Android.
Very,
you still
very
need
important.
to do that, right? I mean, you still need to know exactly how Android works, how iOS works. It's not going to be magical, and much like if you're coding in the Windows environment and you want to learn ASP, it's very different APIs than if you're trying to learn WPF or some other platform within the .NET framework. Right?
Yeah. So
this is no different.
So that's a good point. And those of you who have no iOS or Android experience, something like Xamarin Forms might be a good place to start, because it doesn't require you to know quite as much as the platform, about the platform specific, as much on the platforms. So let's take a look at our main activity and our task details activity very quickly. So our main activity, in our main activity, we would inflate our main layout here when we come into the class on create. So on create is kind of like view did load in iOS, as we've seen, and we have on resume here, which is sort of like our view will appear. So same thing as the iOS app. We're going to get our tasks. Difference here is that we have a list view instead of a table view. And again, to keep things simple, we just have an add task button. There's no double clicking to add the event here. You have to actually wire it up manually, just like in Eclipse for Android. So we would declare our controls up at the top here, and we would initialize them and add the click event. And for the list view, we would add a click event for that as well. And instead of a data source on our list view, we assign an adapter. And in this case, it's a very standard array adapter. We pass our object type, and we pass the context, which is this class. And then we pass our task objects. So if we take a look at our task details view, completed. I was hoping to do all this from scratch, but not in this amount of time, obviously. So I guess let's just run it now. So we have to set our startup project, and we have our Android emulator already running. We'll just see some of the same behavior. So we want to add a task. Again, task 1, 1, save. I don't want to bore you too much with this.
Both applications using different data sources.
Both applications are referencing the core. And if we come into the detail, we can see that we're doing essentially the same thing. We're creating our Tasky API and passing the platform-specific instance of SQLite and the database path on Android, which is different. But a lot of things are similar. Now, we save our task, we call add task. Again, a lot of the same things. Instead of popping our view controller here, we're going to call finish on the activity. And that's going to unload that activity. And that's pretty much it.
You can see how the UI is a little bit different, right? What I was talking about before. And just the constructs on the different platforms is different. For those of you who have used both platforms, you'll know, the back button doesn't exist in iOS, right? So you have to code for that in your app. So the APIs are slightly different, but the benefit of essentially sharing like what you want to do with your code. For example, if you have in most of mobile apps today have some sort of connectivity features where you have a remote API that you're coding against and things like that. Pretty much all the code to integrate to HTTP client on the client side to integrate to a remote web API. It's the same. Like, why would you want to copy that in 3 different places? And here you put all that code in your core project and reference that code from both project or using library, the native approaches, and you're good to go.
So just a couple follow-up slides. I know it's a couple minutes to 12, so there's a little more information here. Xamarin University is a great place where you can learn more about Xamarin. There's a lot of good classroom videos. You can take live classes, you can take pre-recorded classes, and there's all kinds of class materials. You can go from very introductory all the way to very advanced. There's a sample application you can download called the Xamarin Store. And if you do this and just run the application and go through the store, you'll get a free C# t-shirt.
You have to make a
pretty
little bit
cool.
of a change, right? Like a little bit.
Yeah, there might be like a line of code, or yeah. And then Evolve has tons of Xamarin related videos, really cool videos on there.
I always like the developer conference for Xamarin. Xamarin has grown quite a bit. It has right now about 600,000 registered developers.
More, quite a bit more.
Now? Okay,
I think it's over 800,000 now.
So there you go. So
30,000.
More recently than I did, but they are like, I mean, that community is essentially growing a lot. So yeah.
So yeah, I'm going to be sending you guys a recording of this and some additional materials, the sample application. You can download this Tasky sample application, but my version is a little bit different. It's a lot more simplified, and I think that it's a lot easier to follow. So if you're looking to get into Xamarin, I think you should definitely check out my example here.
And you can download all of that stuff for free, basically, on the website. Up until the time that you're actually going to publish the application to the App Store is when you're going to need a professional license for doing the publishing. But you can run off of your phone, you can run off of the emulator, you can run pretty much anywhere for free. Just go to the Xamarin Studio or the plugin that you can use with your Visual Studio and essentially do pretty much the same stuff. Another thing that we're going to mention here is Pluralsight also has a couple of videos. They are a little bit outdated, two of the courses in there, but I know that we all have access to Pluralsight, and those are good kind of foundational videos that you can go and use as well.
With the changes now in the fact that the .NET is open source and all that, how is that affecting or is influencing, or what changes in Xamarin can we expect from that?
I don't think there's any change in Xamarin themselves. I mean, first, .NET is not completely open source. It's only the core, .NET Core, what is open source. And 100% of the .NET Core is already mapped by Xamarin. The Mono project, which is the one that actually does all of this thing, is completely open source as well. So you can actually go. They've been open source forever.
So that is not very.
I don't think that there's any impact. Would you say?
No, I mean, it's hard to say. We'll have to wait and see. But I mean, right as of this moment with Mono and everything else, like I said, we're running .NET pretty much on any platform.
Yeah.
So it's kind of amazing how much they've ported Mono all over everything else. So even on the mainframe if you want. So.
Right.
I don't know why, but yeah, you could. I mean, if you run .NET for the mainframe, so it's kind of like, that's an interesting.
Do you guys have any questions, concerns? I mean, Jesse here, you've got the expert on
I know
that.
my whole thing. When I looked at Xamarin Studio previously, they have a 16K limit to the amount of code you can compile. Is it still the same?
So I think that used to be like that for the indie version.
Yeah.
For the
I don't
free
know if that's
version.
Still the case?
Not for the indie version, for the free
For
version.
the free version.
Yeah, it's very limited.
Yeah.
The indie version is pretty, did I have that here? It's pretty inexpensive. They say for a team of up to 5 developers.
It's like $900 or something like that, right?
Or it's like 25 or 35 a month.
Yeah, we're in the process of negotiating. I mean, the whole Xamarin licenses and everything else, and we have a couple projects teed up for Xamarin as well. So it is on our roadmap for short term.
Anything else? No? All right. Good.
Are you guys gonna? Thanks for coming, guys.